Hi guys, and welcome to this video on exact ratios. Okay, let's just consider this following isosceles triangle. I've made it, have two side lengths equal to 1. I could have both of them 2 or 3, but just for, making it a little bit easier, let's just call each side length 1. So if I had an isosceles right angled triangle, what would be the other two angles? Okay, so they should be 45 because angle sum of a triangle will tell us that the remaining two angles will be 90 degrees, and because it's isosceles, base angles in an isosceles triangle are equal. So therefore we've got those two angles, those two base angles being 45 degrees. What would be the length of the hypotenuse? Okay, so there's the hypotenuse. How can we work that out? So let's just call it x. That would be equal to, x squared will be equal to 2, so x will be equal to the square root of 2. Let's just leave it like that. We don't want to evaluate that, so that, if you can remember, is surd form, so let's just leave it in surd form for a moment. Okay, let's have a look at our three ratios now. So our first ratio, which is, sine of our angle. So let's just look at this one. It doesn't matter which angle we look at, which 45 degree angle, because we'll still have the same ratio. So opposite over hypotenuse. So there's opposite, here's hypotenuse. So for the sine of 45, that's always going to be equal to that ratio, 1 over root 2. If we work that out on the calculator, sine 45, that's roughly equal to, 0.707. Roughly equal to that. So, that will give you a decimal answer. It's not exact. This is an exact form, 1 over root 2. We can call it 1 over root 2 or 1 over the square root of 2. And that's in exact form. Whereas if we use our calculator, there's an approximation. Okay, so if we look at adjacent over hypotenuse, so here's our angle, there's adjacent, there's hypotenuse, we end up getting 1 over root 2 again. So, our ratio for cos of 45 is 1 over root 2. And the last one we'll look at is, tan 45. If you can remember TOA, which is opposite over adjacent, here's opposite, here's adjacent, and we end up getting 1 over 1, which just is equivalent to 1. So tan of 45 is equal to 1. These three so far, well, there's going to be more to come, but these three at the moment are very important to remember. Okay, so in the previous one we had a look at an isosceles triangle. Here I've got a particular type, which is an equilateral triangle. All angles are 60 degrees and all side lengths are the same. I could choose 1, 1, 1, 2, 2, 2, 3, 3, 3. I've chosen 2, 2, 2 for a specific reason, and here is why. Because I'm going to bisect the angle at the top, which means to cut in half. I'm going to have a perpendicular bisector as well. So I've got a right angle down the bottom, and the 60 degree angle at the top has been bisected, so now this is half of 60. So here's 30 degrees. Now using Pythagoras' theorem to work out the height of this triangle, I could say, okay, let's call it h, so h squared is equal to the hypotenuse squared minus the other side length squared. So h squared is equal to 3, so therefore h is going to be equal to, in exact form or in surd form, the square root of 3. So there's the height of that triangle. So now I can work out my exact values, not for 45 now, but for 30 and 60. So if we have a look at this angle up here, opposite over hypotenuse is going to be a half. You can verify that. If you type in sine 30 in your calculator, you will get a half. And this is the reason why, because in a triangle, when we've got a 30-degree angle, the ratio is in the ratio of 1 to 2. What about cos of 30? Cos of 30, so here's 30. Adjacent is the root 3. Hypotenuse is 2. So the ratio is in the ratio of root 3 to 2. So root 3 over 2 is cos of 30. And opposite over adjacent is 1 over root 3. So this was looking at that angle up the top. That's to get the 30-degree angle ratios. We can also look at this angle down the bottom to work out, sine of 60, cos of 60, and tan of 60. So I'll get you to pause the video and write down the 3 ratios for sine, cos, and tan for 60 degrees. Okay, if you did the sine of 60, you should get, opposite over hypotenuse, root 3 over 2. Cos of 60, which is adjacent over hypotenuse in relation to that angle. So you end up getting a half. And tan of 60, which is opposite over adjacent. That is actually a mistake. That should say root 3 over 1. Okay, sorry for that mistake. So that's root 3 over 1, which is the same as root 3. So tan of 60 is root 3. So how did you go with those answers? Okay, so let me just get rid of that. That's root 3 over 1. So those 9, in future will be very handy to use, because when we do certain calculations, sometimes the expressions work nicely when we know the exact form. Sometimes we might just need to use our calculator, but those 9 would be good to be memorized. Okay. If you don't memorize them, that's okay. You can quickly draw up the triangles and evaluate those. Okay, thank you for watching this video.